Okay, so to do that, what you're going to do is first, you need to put this number here, number 55, inside of your RAM dahulu. Inside of your GPR. Okay, so need to load this value to your GPR first. Okay, before you can send it to these addresses. Okay, so by using the LDI, so load I R17OX55. So what happened is R17 now will have value 55. Okay, after you put this value to inside of your GPR, then after that you can send out to these addresses. Okay, how to send out this value to these addresses? So by using the STS instruction. Okay, STS means that store from memory space. Okay, store to memory space, in which STS 0x140 R17 means that now you save or you store value inside R70, which is 55, to a memory location of 140. And then you write down the same instruction. Okay, you copy back the same instruction, but now change from 140 to 141. Okay, and then R70. So what happens after you execute this instruction is R70 now, the value from R70 is stored to the memory location of 141. Okay, next you copy back the same instruction. STS now change to 0x142 R17. So R17 value from R17 store to address 142, and then STS 0x143 R17. So now you save the data from R17 to a memory location of 143. And last but not least, because you're going to send out from address 140 to 144, then you copy back the what we call here the same instruction STS 0x144 R70. So this is how you're going to send this value 55, okay, into the memory location from 140 to address 144 by using direct addressing modes. Okay, so next we are going to use the indirect in the addressing mode, but without a loop. Okay, so how to do that? So since this is indirect addressing mode, so you need to use the pointer register lah. Okay, you need to use the pointer register, either pointer register X, Y, or Z. We have a 3 pointer register. You can choose any from this one or any from these 3 here. Okay, so in this case here, we take a Y lah, pointer register Y. In this example, we use the pointer register Y. So first, what you're going to do is sama juga lah. Okay, what you're going to do is you need to put value 55 to your GPR, which is now you save to your R16. Okay, so by using the LDI instruction, so LDI R16 OX55. So what happens is you load 55 to R16. So R16 sekarang ni have value 55. Okay. Okay, now we are going to use the what we call here the pointer register. Okay, so you need to make sure lah. Okay, you need to make sure that your pointer register have an address which is starting from 0140, because this is our starting address. So make sure that the pointer register Y pointed to this address 0140. So how to do that? Macam mana nak buat? Can somebody please tell me how to point your register Y so that it pointed to this address, the starting address of 140. How to do that? Okay, so since this address here, okay, is 16-bit, so kamu boleh divide it to 2 byte. Okay, one is a low byte and the other one is high byte. So 40, okay, this 40 here, you put to your YL, while 01 you put to YH. Okay, so how to point this 140 to Y? By load this value to your YH and YL. So that's why we use this LDI YL OX40. So what happens is, okay, after you execute this instruction here, apa yang berlaku is your R27, 28, okay, will have what value here? 40 and load I YHOX1. So what happen after you execute this instruction, your R29 now will have 01. Okay, so since this is R29, R28, okay, R28 is 40 and R29 is 01. So now what happen is your Y now, your pointer register Y point to this address 0140. Okay, next what you're going to do, then after that we can store lah by using the ST instruction. Okay, so STYR16 means that you copy the value from R16, which is content of 55, to memory location of 140. Kenapa? Sebab Y now pointed to address 0140. Okay, and then next we are going to increase the R28. Macam mana, how to increase the R28? So that the Y, the new Y will point to address 0141. So how to increase from 40 to 4Y? By using the INC instruction. So what register that you're going to increment? Is it R28 or R29? So of course lah, we need to increase the R28. Sebab R28 have the value 40. Okay, so that's why increase R28 ataupun you can use the increase INCYL. So what happen is you increase the low byte of YL. So now what happen is your YL change from 40 to 41. So automatically Y pointed to new address 0141. Okay, and then you store again by using the STYR16. So what happen is copy the value 55 to a memory location of 141. So you need to increase again, okay, your R28 or your YL, so that it's pointed to address, okay, so that it point to new numbers, which is 42. Okay, because the next address that you're going to store the data is to the address 0142. So we increase again our YL. Okay, so increment the pointer register. Okay, so now what happens is YL have 42. Okay, so automatically your Y point to new address 0142. Okay, and then you store. Do store again by using the STYR16. And then increment again your YL. So now YL sama dengan 43. And Y point to new address 143. Store again, okay, by using the STYR16. So copy your R16 value, which is 55, to memory location of 0x143. And then increment again your YL. So now your YL point to address 44. And then Y is now actually pointed to new address 0114. And then store again YR16. So this is how you're going to send 55 value to address 140 to address until 144 by using indirect addressing mode, but without a loop. Okay, tanpa loop. Any question? Okay, so your friend here asking that can the ST be replaced with LD? Cannot. Why cannot? The LD, okay, since both of them is store and load the data, but LD used for the GPR, while ST used to store the data inside of your RAM. Okay, the LD only for the GPR from R0 to R31. Cannot use for the RAM. Okay, now we go to the C, which is by using the indirect addressing mode, but with a loop. Okay, so again, sama juga, you have number 55, you're going to send to address 140 to 144. Okay, so now you are going to use a loop. So how to do that? Macam mana nak buat? Okay, first, you need to find out how many loops you going to do. Okay, macam mana nak dapatkan how many loops you going to do is by using the, okay, this is your starting address, this is your end address. Okay, by using the formula end address minus start address plus with 1. Okay, that is the number of your loops. And minus with start address plus 1. Okay, since this one here is 1 for 4, minus 1 for 0, you get 4, and then plus 1, so the number of loop is 5. Okay, so that's why here you see the first line here, this is your counter lah, dia punya looping counter. Okay, ataupun your counter register. Okay, load I R16OX5. Okay, this is your the number of loop that you're going to do lah. Okay, you're going to create. Okay, so since you're going to store to 5 different location, so the number of loop is 5 lah. And then load I R2055. Okay, this one here, you're going to load 55 to R20 because we're going to send out the number. Before we're going to send out the number to your RAM, we need to put that number to our GPR first. Okay, so this one, what happens is, okay, this is R16 equal to 5. Okay, and then this is R20 equal to 55. Okay, and then because this is indirect addressing mode, okay, so you need to use a pointer register lah, either X, Y, and Z. So we use the same pointer register. What is our starting address? Dekat address 140. Okay, so you divided this address here so that it has 2 bytes. One is a low byte and the other one is for the high byte of your address. Okay, so low byte will have value 40 and high byte will have value 01. So that's why we put the load I YL0x40 and load I YH0x1. So what happens is, after you execute these 2 instructions here, Y now point to address 014, which is your starting address. Alright, so next, what are you going to do? Okay, we store the data to this address, okay, by using the ST instruction. So STYR20. So what happens is, R20 value from R20 you store to address that pointed by Y, which is the address 0140. So ada value. So this is address 0140 akan ada value 55. Okay, and then we're going to increase the address so that the next address will be 0141. So macam mana nak buat? So we need to increment the YL lah. Okay, so increment your YL because now your YL is, this is your YL. The current value of YL is 40. So you want to increment to 41. So by using the INC YL, so now your YL become 41. Okay, once you increment the addresses, the RAM addresses, so next what you're going to do is you need to decrement your counter. Okay, decrement your counter. So decrement R16. So what happen is R16 sekarang ni, okay, the current value is 5, your decrement it become 4. Okay, and then we use the branch instruction BRNE. So what the BRNE do? This BRNE will looking at Z status register. Okay, means that this is for BRNE, it stands for branch not equal. Means that if the number is not equal to 0, it will keep looping. Okay, when the R16, okay, when the Z equal to 0, okay, when the value of R16 is 0, what happens? It will stop looping. Okay, so because this one here, R16 still have value. Okay, so what happens is it will go to L1. Kat mana L1? Here is your L1. Dia akan lompat to your L1. It will branch to your L1, which is you need to store again your Y with R20. So your current Y now point to what address? 0141. And sekarang ni dia akan store 55. And what happened to your... And then the next instruction is you need to increment back your YL. So YL sekarang ni jadi 42. Okay, decrement R16. So R16 now become 3. Branch not equal because the R16 still have value. So it will branch and store again YR20. So kat sini akan jadi 0142. You store again 55. Increment YL. So YL now become 43. Decrement R16. R16 become 2. Branch not equal. So go again to your L1 here. So store again the value. So this one will become 55. And then increment YL. YL now become 44. Decrement R16. R16 become 1. So still have value. So branch again. It will looping again here. Okay, they can keep looping. And then store YR20. So what happen is at this addresses, you store again number 55. And after that, you increment your YL. So your YL now point to what address? 45. And then decrement R16. Okay, since this one here, after you decrement minus, the current value is 1. After you decrement, it becomes 0. So what happened is, so now you need to exit of this loop here. So it will go to the next instruction, which is somewhere around here. The next instruction below the BRNE L1. Okay, so this is how the looping works. Okay, how to use the loops. Okay, so looping is not possible in direct addressing mode as opposed to indirect addressing mode. Okay, so why? Because of this increment. Okay, because you're going to increment your YL, so we need to use the indirect addressing mode instead of using direct addressing mode. In direct addressing mode, you cannot do the looping. Okay, so any question? Ada soalan tak? Okay, for example lah. Okay, now you're going to sekarang ni. Okay, we save. We're going to save the value from address 140 until 144. Let's say lah, it asking you to save the value from 140. Oh, my what we call it? Is it my audio is you putus-putus ya? Okay, sekejap ya, sekejap. I check my internet connection first. Okay, so we take the same example. Okay, instead of store the data, the same the number 55. Okay, the same data starting from address 140 to 144. Now you store it to, for example lah. Okay, we change it. Sekejap, mana saya punya PowerPoint? Alright, so we change it to, for example, 200. So how to do that? Masih putus-putus ya? Okay. So let's continue. If putus-putus again, then you need to inform me. Alright, so let's take the same examples. So instead of so now we're going to save the value. Okay, starting from address 140 to address 200, for example. So what you're going to do? Okay, so if you're going to use the what we call here the direct addressing mode. Okay, so this is direct addressing mode. So you need to copy this what we call here this STS here. How many times? From 40 to 200. Somebody please tell me how many times that you need to copy the same instruction STS ya. Okay, 200 minus with 140. This one in hexa ya, not in decimal. Kalau you put the 200 minus 140 equal to 61, that one is decimal. This value in hexa. Please press the calculator. I don't have calculator. 200 minus 140 plus with 1. C1. Okay, C1 equal to 193. Is it correct? Betul tak? 193. I assume 193 lah. Okay, so because all of you got 193, so takkanlah you nak copy the same instruction 193. Betul tak? 193 times. Okay, which is quite tedious lah if you're going to do that. So that's why the direct addressing mode is a static way to addressing the data. Okay, compared to indirect addressing mode. So by using the indirect addressing mode and with a loop, janganlah guna without a loop. Without a loop also you need to copy the same instruction here, which is this one here. Mana ya? Okay, this one here, these two instruction here, 193 times, which is not what we call here, not efficient lah. Okay, so instead of what we call here using the direct addressing mode, we using the indirect addressing mode. Okay, with a loop. Now what you're going to do? Where we were going to change the programming? Kat mana kita nak tukar? Okay, we use the same programming, but we only need to change here dekat you punya counter. Okay, only change to your counter. Okay, so now you're going to load IR16. Okay, you just simply replace with load IR16 193. That's all. Okay, so this program here will store the value from address 140 until 200. Okay, so that's why we need to use the indirect addressing mode compared to direct addressing mode. If you're going to store many data lah, if you're going to store just a few data, so you can use the direct addressing mode. Okay, so next we are going to see the auto increment and auto decrement option for the pointer register. Okay, because the pointer register X, Y, and Z are 16-bit register, they can go from 000, address 000 until FFF. Okay, in this case, in Article 32 until 085F. Okay, but using the increment ZL instruction, okay, by using this instruction here, to increment the pointer can cause a problem when an address such as 555 is incremented due to I increment ZL will not propagate the carry into the ZH register. Okay, contoh lah. Okay, so now you're going to what we call, we take the same example tadi. Okay, we were going to store from 140 to address 200. Okay, if you going to use the what we call here the previous punya method, okay, indirect addressing mode, by increase your YL by using the increment YL. So what happen is so now let's say lah dia sekarang ni dekat addresses. Okay, so now your Y, okay, this is your Y, point to address 01FF, which is you need to increment so that it point to the next address, is the new address is 200 lah. If you do that, what happen is if you increment YL, so this is your YL. Okay, if you increment YL, what happen is your YL now become 00, but your YH remain 01, which is wrong lah, because the what we call it, the carry from here not propagate to your y hash. So this is the what we call here the drawbacks lah by using the increment ZL. So in order to what we call here, in order to overcome that, okay, we use the auto increment or auto decrement option. Okay, so this is the reason lah kenapa kita using the auto increment and auto decrement to overcome this kind of problems. Okay. So auto increment, which is a push increment, is available with your pointer register X, Y, or Z. Okay, so macam mana how to identify that Y belong to auto increment or auto decrement? Okay, so auto decrement, you see the plus sign here dekat situ. Okay, so for auto increment, okay, you have two instructions that involve auto increment. One is for the LD, and the other one is for the ST. Okay, so for the LD means that you want to load indirect with post increment, while ST is store indirect with post increment. Okay, so this is for the auto increment. Okay, so this auto increment typically used in a looping structure to sequentially access memory by increasing the address. Okay, so set Y for the first byte. So sama jugalah, you need to set your pointer register so that your pointer register point to your pointer to the address that you're going to store or you're going to load. Okay, access repeatedly using the post increment to point to the next byte after each accesses. Okay, so this is an example by using the LD. So the syntax is LDRD Y plus. If you're going to load the data lah, if you're going to store the data, the syntax is ST Y plus R RR. Okay. So later we will see the examples for this auto increment and auto decrement. Okay, for the auto decrement, register indirect with auto decrement. This one also typically used in a looping structure. Okay, every time you're going to use the looping, okay, you're going to create a looping to sequentially access memory by decreasing the addresses. Okay, so set Y to 1 minus address of the last first byte, and then access repeatedly using the pre-decrement to point to the byte accesses. Okay, so this one here. Okay, so this one we call it as a pre-decrement. Kenapa pre-decrement? Because you need to minus your pointer register address, and then after that you load the data or store the data. Compared to this one, you store the data first or load the data to your address, to the address that pointed by your pointer register, and then after that you increase your pointer register. Okay, untuk yang auto decrement, you need to minus dahulu. Okay, minus your what we call here the address of the pointer register, and then after that you load or store to that address. Sebab tu dipanggil this one become the pre-decrement. This one here we call it as a post increment. Okay, yang ni post increment and pre-decrement. Hello, dengar tak? Sometimes tak dengar ya. Sekejap I restart my router dulu. Okay, and then we continue our class. Okay, give me around 5 minutes ya. We take 5-minute breaks and then we continue with our class.